Assalamu alaikum students. This is fifth recorded lab session of biosignal processing course. In this lab session, you will see how we compare biosignal using autocorrelation and cross-correlation method. When we want to compare signal, we often use basic properties like mean, variance, standard deviation of signal as we did in one of the previous practical in which we computed standard deviation to compare heart rate variability under two conditions. First was meditative state and the second was normal state. But sometimes these basic properties are not useful in capturing all the relevant and important features of the signal. Therefore, to gain more insight, we do complicated analysis such as correlation and transformation. So when we want to compare two signal or we want to compare how one function is like another function, then correlation basically provides a quantitative way of comparing two functions. For example, when you have given an EEG signal and you want to find the presence of alpha rhythm in your EEG signal, then what you will do? You will cross correlate your signal with the signal having an alpha rhythm. So by cross correlation, you can easily find the presence of alpha rhythm in given EEG signal. So based on the availability of the reference signal, there are two types of correlation. First is autocorrelation and second is cross correlation method. So when we want to compare one signal with another signal, we do cross correlation. Cross correlation basically shows the similarity between two waveforms at all possible relative position of one waveform with respect to the other waveform. It is useful in identifying the segment of similarity between two functions, as I have given you an example, to find the presence of alpha rhythm in EEG signal. So to do so, you will cross correlate this signal with the signal having alpha rhythm. But when we want to compare signal with itself, then a way of doing so is autocorrelation. Autocorrelation is basically a special kind of correlation method. In this method, function is correlated with different shift of itself to see how much the signal is similar to itself at various time shifts. Now there are some basic properties of autocorrelation function. First property of autocorrelation function is that it will be maximum for zero lag, because at zero lag the comparison is between two waveforms. The signal is compared with itself. Therefore, at zero lag you will find correlation maximum, and when we talk about normalized coefficient, it will be 1. As you can see in this figure, at zero lag correlation coefficient or the value of correlation is maximum. And the second property of autocorrelation function is that the function or the waveform will be symmetric about time or time shift or lag 0. So you will see symmetry at 0 lag, because as you can see in this figure, shifting of one version of the same waveform in the negative direction will be same as shifting the version of the signal in the positive direction. So at 0 lag, you can see the waveform is symmetrical. About mathematical formulation of correlation function. Linear correlation between two function or signal like x and y as a function of time t can be obtained using the formula given here. This formula will be used to obtain correlation function for the signal as a function of time t. Here the time span is from 0 to t. For discrete time signal, this t will be replaced by k and capital T will be replaced by capital N. It is also common to modify these two equations to obtain normalized form of the correlation. So to obtain normalized form of the correlation, you will divide correlation obtained by using equation 1 and equation 2 by the square root of the product of the variances of two signals. Here sigma 1 square represent variance of first signal and sigma 2 square represent variance of second signal. So by using normalized form of the correlation, if there is value equal to 1, then the value equal to 1 will indicate that two signals are identical. If you get -1, then it will indicate that these two signals are exact opposites. Now how you will perform autocorrelation and cross correlation in MATLAB? Actually, MATLAB has specific routine for performing autocorrelation and cross correlation, which is called Xcore. This Xcore treat autocorrelation as a special case. Here you can see this Xcore function has some input arguments and some output arguments. X and Y are the inputs. If you specify X and Y, then it will perform cross correlation. If Y variable is not specified, then it will perform autocorrelation. Here you can see max lags and options, which are the optional argument. I will describe them in the coming slides. Here C, lags are the output arguments. Now there are some input arguments. These are optional input arguments of the Xcore function. These input arguments are maxlax and options. Maxlax actually specify shifting range. If you specify maxlax as an input argument to the Xcore function, then the waveform will be shifted between plus minus maxlax. If you do not specify any maxlax value, then the default value will be -n to +1 to n -1. Here n represent length of the input vector. Now you can also provide multiple option as an input argument to the Xcore function. For example, if you want your output to be biased, then you will provide biased as an input option to the Xcore function. So by using biased, the output will be divided by 1 over n. If you want correlation coefficient as an output, or as at output you want correlation coefficient, or at 0 let the autocorrelation value must be equal to 1, then you will use coefficient as an input argument to the Xcore function. If you do not want any scaling, you can also specify none. None is also a default option. Another important point to remember about Xcore function is that it does zero padding. In case if one of the waveform is shorter than the other, then the shorter waveform will be zero padded, so that two waveform must be of same length. Here the output variables are C and lags. The description of C is that it is a vector of length 2 times maximum lag plus 1. If you specify maximum lag as an input argument to the Xcore function, then the length of the variable C will be 2 times maximum lag plus 1. If you do not specify maximum lag as an input argument to the Xcore function, then 2n-1 will be the default range of this output variable C. And another optional output argument is lag. Lag is basically a vector of integers ranging between plus minus lags, maximum lags. And this optional output variable is useful in plotting. Now in case if you want to compare a number of signals, then MATLAB, about this to do this, MATLAB has a dedicated function called core coefficient. Core coefficient calculate correlation between different combinations of the signal. Here you can see X is the input to the core coefficient routine. X actually represent a matrix that contain various signals to be compared in columns. So to compare multiple signals at a time, you need to create a matrix. The columns of the matrix must contain signals which are to be compared. At the output argument is R XX. Now the output of core coefficient is a matrix. The dimension of this matrix will be n by n. Here n represent number of the signals to be compared. For example, if you compare 3 signals, then the dimension of the output matrix will be 3 by 3. Here you can see diagonal of the matrix represent correlation of the signal with themselves. Therefore, they will always be equal to 1. If you see off diagonals, Off diagonal basically represent the correlation coefficient of various combination. For example, R12 is the correlation between signal 1 and signal 2, whereas R21 is the correlation between signal 2 and signal 1. And you can see the correlation of signal 1 with signal 2 will be same as signal is the correlation between signal 1 and signal 2. Therefore, this matrix will be symmetrical about diagonal. Now regarding the MATLAB implementation and see the working of described functions, we will perform some lab activities. First lab activity is simple, in which we will use MATLAB function to find correlation between sine wave, cosine wave and a square wave. In second lab activity, we will use biosignal, that is EEG signal. We will cross-correlate this EEG signal with the range of sine wave having frequencies between 1 to 25 Hz. Frequency increment will be 1 Hz. Or this lab activity is to find that to which frequency or to which signal EEG shows maximum cross correlation. Now the steps for second lab activity is given here. First of all, you will load your EEG signal, and then you will use a loop to generate a series of sine wave from 1 to 25 Hz with an increment of 1 Hz. And then you will cross correlate the sine wave with the EEG signal. After this, you will find maximum cross correlation. After finding maximum cross correlation, you will plot this maximum cross correlation as a function of sine wave frequency. Now to see the working of code of first lab activity and second lab activity, view the second part of this recorded lab session.